Okay, so in this video, I'm going to give the solution of 2008 step 3 question 4. And the first question in this step question is asking us to show with the aid of the sketch that y is bigger than tanh y over 2 for every y that is bigger than 0. So the identity we want to the inequality we want to show is this, and I think this question is not very difficult because by noticing that for y is bigger than 0, so this is your y equals x. And if you draw the graph of tanh y over 2, you will end up with a graph like that. This is y is equal to tanh x over 2. And you can immediately get your result that x is bigger than tanh x over 2 for x is bigger than 0. Okay, because this is not very difficult because the graph of y equals x is always above the graph of tanh x over 2. And the next sub question is asking us to deduce that this inequality is true. And I personally think that if you just staring on this inequality, then the answer won't come from nowhere. And if you want to use some kind of hacking method to have the result of this sub question immediately, it is not very realistic. So the property of a step 3 question is that every question that is listed by the question, every kind of sub question, for example, this is a sub question, this deduced question is a sub question of question 1. Every sub question, the result you want to prove of the sub question is always involved the result that you derived before. So what I mean is the result we derived before, y is bigger than tanh y over 2, is actually related with this result that we are going to prove. So it definitely links the result of this definitely links the kind of precise procedure of proving this inequality. So how do we get how do we go from here? How do we go from here to here? I think the most obvious way is that if you want to get from tanh to cosh, the most easy way is just to square both sides and apply hyperbolic identity. And let's see what will happen. So y squared is bigger than tanh squared y over 2. So this is a square of your result. And then from hyperbolic identity, we have cosh squared x minus sinh squared x is equal to 1. This is our hyperbolic, very basic hyperbolic identity. So if we divide both sides by cosh squared x, you will have 1 minus tanh squared x is equal to sech squared x. So by applying this identity to our inequality, we will have y squared minus 1 is bigger than negative sech squared x. Sorry, it's not x, it's y over 2. And then multiplying the negative sign to the left hand side, we will have 1 minus y squared is smaller than sec squared y over 2. And obviously we find that this term is very hard to handle. If we want to somehow convert this into the form of cos y, the first thing we need to do is, I think, is to apply hyperbolic double angle formula. So cos 2x is equal to cos squared x plus sinh squared x. So from this, we will have 2 cos squared x plus 1. Okay, so so if we send all our x to let me see, all our x to x over 2, we will have cos square x over 2 is equal to cos x minus 1 over 2. So, okay. So here, we will have, let me see if I did this correctly. Wait a second. Oh, it's minus 1. It's not plus 1, it's minus 1. So, okay, sorry. Yes, it is plus 1 here. And then substituting this result into this inequality, we will have 1 minus y squared is less than 2 over cos y plus 1. Yes, I believe it is correct. Okay, and then rearranging this inequality, we will have cos y is less than 2 over 1 minus y squared minus 1, right? If we convert the denominator with left hand side and subtract 1 from each side, then we will have this, which equals 1 plus y squared over 1 minus y squared. And now, and the next step is actually quite tricky. We want our inequality to comprise the term of arc cos y, which is simply the inverse of cos y. These two are the same. It's just the different notations. So we can just directly take the inverse of both sides. We will have y is less than arc cos 1 plus y squared divided by 1 minus y squared. And I think we have the right sign of inequality. The sign we want is just this sign, which is same as this. And then, but the term that is comprised in the arc cos term is not very optimistic, in terms of solving this question. So here's what we want. We want 1 plus y squared divided by 1 minus y squared. We want this term to be sent into y, and then we will have a nice looking arc cosh y. So in order to achieve this, we need to set y, sorry, maybe this place is too narrow. We will send here. We will set y equals 1 plus x squared divided by 1 minus x squared. And by rearranging this equality, we will have 1 plus x squared is equal to y minus yx squared, which is same as x squared 1 plus y is equal to y minus 1, which gives us x is equal to the square root of y minus 1 over y plus 1. So if we send this term to y, it is equivalent to send our y to the square root of y minus 1 y over y plus 1. So the inequality we already have is y is less than or equal to arc cosh, let me see, arc cosh 1 plus y squared 1 minus y squared, 1 plus y squared over 1 minus y squared. And if we send all our y to the square root of y minus 1 over y plus 1, we will have arc cosh y. So this term is directly sent to y is bigger than the square root of y minus 1 divided by y plus 1. But the form we want is actually x minus 1 over x squared minus 1. So here we just do a little trick. This term is equal to y, the square root of y minus 1 over the square root of y plus 1, which is same as the square root of y minus 1 times the square root of y minus 1 over the square root of y plus 1 times the square root of y minus 1, which gives us y minus 1 over the square root of y squared minus 1. And this forms the inequality we want in the first question. So this is our first question, and this is our second question. And in our second question, it says by integrating this star, show that arc cosh x is bigger than 2 times x minus 1 over x squared minus 1 for x is bigger than 1. So for x is bigger than 1 is actually very obvious, because for every arc cosh x, you have to have x that is bigger than 1. So right here, so yeah, all we want to do is just to integrate the star. Where's my mouse? Okay. So integration cos inverse x dx is bigger than integration x minus 1 over the square root of x squared minus 1 dx. And so we firstly integrate our left hand side. For our left hand side, we can just set u equals cos inverse x. Then we will have x equals cos mu. Then we will have, if we take derivative of both sides, we will have 1 equals sinh mu times d mu dx, which gives us that dx is actually equal to sinh u du. So the left hand side is equal to integration mu times sinh u du. And this is actually very easy to integrate. We can just apply it. We can just apply integration by parts on this integral. So integration by parts, u1 dash is equal to sinh u, v is equal to u, and u1 is equal to cos u, v dash is equal to 1. So our left hand side is equal to u cos u minus integration of cos u du, which is equal to u cos u minus sinh u. And this is the result of our left hand side. And for the right hand side, RHS is equal to integration x minus 1 over the square root of x squared minus 1. Integration x minus 1 over the square root of x squared minus 1 dx. So for this question, we can actually solve it very easily by trigonometric substitution. But this is not the way we want to solve this question. We want the result of this integral to contain some hyperbolic terms. So basically, we just need to use hyperbolic substitution to solve this question. So by the hyperbolic identity, cos squared x minus sinh squared x is equal to 1, we can just set x is equal to cos mu, and dx by d mu is just sinh mu, and our integral will be changed into x is equal to cos u, so cos u minus 1 over sinh u times sinh u du, which gives us the integration of cos u minus 1 du, which is just sinh u minus u. And now we rewrite our inequality. So the inequality of integration arc cos x dx is less than or bigger to. So this is bigger than integration x minus 1 over square root of x squared minus 1 dx. So this inequality is equivalent to the inequality u cos u minus sin u is bigger than sin u minus u. So this is the inequality we'll have. And how could we derive the form that we want? Basically, it's just this form. How could we derive this form of inequality from this? So the first thing we want to do is just to rearrange this inequality, which gives us u cos u plus 1 is bigger than 2 times sin u. And now here is a very tricky trick, which is just to send all our u to arc cos x. And now we will have arc cos x times so u is sent to here, so this term will be x plus 1 is bigger than let me see, 2 sin arc cos x. And this term is actually equal to so from the hyperbolic identity here, and we can easily convert this into the square root of arc cos x. This has a square right here, minus 1, and which is equal to the square root of x squared minus 1. And by multiplying 1 over x over 1 or 1 over x plus 1 on both sides, we will have arc cos x is bigger than 2 times the square root of x squared minus 1 over x plus 1, and which is very close to the result we want to have. We won't have 2 times x minus 1 over x squared plus 1. So in order to achieve this, all we need to do is just to change our right hand side into 2 times the square root of x plus 1 times the square root of x minus 1, and in the denominator we will have the square root of x plus 1 times the square root of x plus 1. And now those two square roots are cancelled, and now if we multiply it by the square root of x minus 1 on both numerator and denominator, we will have our right hand side is equal to 2 times x minus 1 over the square root of x squared minus 1. And this is our goal. So second question is completed. And for the third question, show that arc cos x is bigger than 3 times x squared minus 1 over x plus 2. So as I said, this inequality seems very messy and came from nowhere, and you don't know how to approach this. But the property of a step question is that every result you want to prove may use or may involve the results you have proven previously. So apparently those two results may contribute to this, but the most significant factor contributed to this to proving this inequality is that the method of integrating both sides. So if we integrate both sides of this inequality, we may have some surprising discoveries. So if we integrate both sides of this inequality, integration cos in arc cos x dx is bigger than 2 times the integration of x minus 1 over the square root of x squared minus 1 dx. And the result of this is actually proved by me or computed by me, which is u times cos u minus sin u, and this is bigger than 2 times the result of this integral is actually very clear as well. We have proved that, we have computed that, which is just sin u minus u, 2 times sin u minus u. And we do exactly the same as we did before. We will have u times cos u minus plus 2 is bigger than 3 sin u. And now we do exactly the same. We send all our u to arc cos x. Then we'll have arc cos x is bigger than 3 times sin arc cos x over x plus 2. And the term on the numerator is just equal to the square root of x, the square root of x squared minus 1 over x plus 2, which is just our result. Okay, so the third question is completed, and this is the end of this video.